All right, guys, welcome to the first Tech Night, I guess we'll call it, because I don't have a better name. This is where I'm going to randomly bring you stuff I did or looked at. Maybe it'll help you and maybe not. Just something to do, something to throw out there. So what I did is I was digging through my old files. I was trying to find uh, a specific capture, and I came across this particular capture I made, and there was only one entry, just the one data capture, and I kind of remembered what was happening. Maybe not for this specific car, but I've done this so many times I could vomit. And so I thought this might be a good example. So what I have here is we have let me bring this up, description. All right. So this was a 98 Firebird with a VIN-K, which is a 3.8 liter engine. And it had a PO 131. Now, there was probably more going on. There was probably some drivability issues. But my experience is most service riders at dealers, which is where I was at, it's like a jack in the box. You pull up and it's like, may I have your order, please? And you say your stuff and boom, you're on your way, your food's coming. And so I can't trust the service rider. I get the car and I have to do everything from scratch. So first thing I'm going to do is check for codes. And so that's what I did. I'm sure I did. I pulled in my stall, I checked for codes, I got a PO 131, and then I'm going to, I kind of have an idea what that code is, at least back then I did, because I saw it many times. So I'm going to drive the car, and I'm going to drive the car for a couple of reasons. One, I want to just drive it, record data, and also, it's a really good idea to drive the car because I've fixed cars before. I've put $1,000 into a repair only to find out that the thing won't shift out of first gear. So I drive the thing to get data and make sure that, I know how it's running and the transmission is shifting. So I got my code. I drive around the block. It's like, maximum 5-minute trip. And I'm back in my stall. I can upload the scan capture from my Tech2 to Tech2Win, or they used to call it TechLine, but it's a snapshot application, and you can see it here. And so now I have it to where I can see it. So we're going to stop here and look at the code. Now, you might be thinking, really? We got to look up a 131? And my answer to that is yes, really, because it's not always the same criteria, and don't assume. So I'm going to pull up. There it is. So here's my PO 131. You can see I looked it up for this 98 Firebird. And we got this nice, pretty schematic, which, it's a whoop-de-doo. It's a O2 schematic. I make fun of it, but you know what? There may be a time when you need to know the pinouts and stuff, but this is, yet at this time, at this point, we don't need to do that. So what I'm looking for is something very specific, and that's the code set criteria. And so conditions for setting the DTC. And so we just read down the list, and the punchline is usually at the end. So the first bullet point is you can't have any of these codes or types of codes. Codes for the math, codes for the whatnot. If those codes are not present, then this test can run. We also want to see closed loop commanded air-fuel ratio between whatever, system voltage, whatever, throttle, whatever. And I'm saying whatever because I don't care. I don't care because I don't trust it. It's usually correct, but not always. What I'm looking for is a punchline, and there's two punchlines here. First one is bank 1, sensor 1, signal voltage remains below 175 milliseconds for longer than 45 seconds during normal closed loop operation. That is an eternity. The other scenario is the signal voltage remains below 600 millivolts for almost a minute during power enrichment mode. Now, how often do we spend that much time in power enrichment mode? It doesn't happen very often. And so anything below 600 millivolts, what we can say about it is this: it's not rich. I'm not going to say it's lean. I'm just going to say it's not rich. And so, in a nutshell, all I needed to know, and what I know now, is that the O2 said the ECM is seeing the O2 signal from bank 1, sensor 1, go too low for too long, and that's it. All right. So with that, let's go. I took the car out and drove it. I got a data capture. Now let's go ahead and bring it up. Well, let's go ahead and try it here first. And you might be wondering, why don't I just use the graphing tool here? Well, here's why. And maybe you know, maybe you don't. There's two ways to graph this application. This one here gives you 3 separate graphs. And we'll just set some here. And this is what it looks like. And so it looks kind of neat, right? You can move the cursor around and see the values change. But let's say I want to put the whole capture on the screen. Now, if you look on the bottom here, there's 626 frames. And on this particular capture, a frame is 200 milliseconds. So if you want to know how long the total capture is, take 626, divide it by 5, and that's how many seconds you have. So it's a pretty good bit of time. Let's see what this tool lets us do as far as time. Here we have frames displayed in the graph. I'm going to put 91 and look what happens. You cannot have more than 90 frames. That's 18 seconds. That's all you can see in one shot. Again, you could play it. Oh, we got to fix it again. Again, you could play it and watch it that way, but really, 18 seconds? The other graph I was telling you about is this one here, and it's the same thing except for it lays it out this way. That's the only difference. So it's pretty limited. And so that's why I go to export to text file. That will save a file that ScanShare or Graphomatic or my old Java applets, I did a lot of different viewers. It exports a file that they can read and I can use. So let's go ahead and pull that up. All right, so let me clear it all first. All right, so my first step. The first step is I want to know, I just did this test drive. Now, even though I just took it, I need to lay out on the graph what's happening as far as engine speed, vehicle speed, throttle, because I need to compare it to other events. But in this case, I haven't seen this capture. This capture was taken in 2005. I haven't seen this thing for like a decade and a half. So let's go ahead and pull up just some basic information. So let's do vehicle speed, let's do throttle, and let's do vehicle speed. There we go. Engine speed, throttle, and vehicle speed. So the first thing I noticed, and this is important, the vehicle's moving. That's important because a lot of my captures, the vehicle isn't moving, and that makes a difference. So the vehicle's moving, and I'm looking at 3 distinct throttle events in which I'm going to look at other data. So the first one is wide open throttle. I got this one here. I got this one here. And this one, kind of partially wide open throttle. So I got wide open throttle. I also have here, we're going to call that part throttle. I got 2 of those. And then the last one, which is very important, is idle. So if you look here, the engine's idling. The vehicle stopped. I'm driving down the road and come to a stop. The vehicle is not moving. My foot is not on the accelerator pedal. This is a cable-driven system, right? Throttle angle is 0%. And so that's my that's my information at idle. So I have the three kind of important areas here. Now, what was my code? The ECM didn't like bank 1, sensor 1. So let's add that to the stuff here. And there it is. So something kind of shouted out at me when I looked at this. And it was in this area here where we're going to zoom in on that wide open throttle. So I got my foot to the floor. We're accelerating. Vehicle speed's going up. And what's happening to bank 1, sensor 1? It's in the toilet. Leaner than snot. Now, that's what the ECM is complaining about. Maybe it's a sensor, maybe it's whatever. So could that sensor be lying? Well, let's try something. Let's go ahead and look at bank 2, sensor 1. And here we're going to fix this so we can see more PIDs. There it is. All right, so my foot's to the floor, engine speed's picking up, the vehicle speed's moving, bank 1, sensor 1's in the toilet, bank 2, sensor 1's in the toilet. So both upstream sensors are in the toilet. They're both leaner than snot. Now, could the two sensors be lying? Okay, well, I'm not pulling out a scope. I'm not going to pull out propane. I'm going to just go ahead and look at the downstream sensor. Where is it at? Where are you at? Bank, there he is. All right. All right, let's do this right. There we go. All right, so I got my foot to the floor. The RPM's picking up. The vehicle speed's picking up. Bank 1, sensor 1 is in the toilet. Bank 2, sensor 1's in the toilet. Bank 1, sensor 3 is in the toilet. Now, what is bank 1, sensor 3? This has a Y pipe. You got upstream sensors on both banks. Then we have our catalyst. And then we have our post O2 sensor on the other side of the catalyst. And we call that bank 1, sensor 3. All three sensors say we are lean. So we're lean. So what do we do now? We want to know why it was lean. So maybe we want to change something here. So let's get rid of these two guys here. And let's add the mass airflow sensor. Now wait a minute. Wait, let's look at our loop status. All right. So foot's to the floor, RPM's going up, vehicle speed's going up, bank, we're in a toilet as far as we're leaner than snot. We are in open loop. Now, what should be going on in open loop? In open loop, in this situation, that's power enrichment mode. We should be running rich, not lean. And so what's the primary input for that? That's going to be our mass airflow sensor. So let's look at our mass airflow sensor. Somewhere up here. There he is. All right, so let's zoom in on that area again. I got my foot to the floor. The RPM is going up. The vehicle speed is going up. I'm leaner than snot. I'm in open loop power enrichment. I should be rich. And what am I reading on my mass airflow sensor? I'm reading 84.58 grams per second. Now, we're trainers. We know that's bad. It's broken, right? But what if you didn't know that? If you didn't know that, that might be an issue. You might do this. You might go to our lambda calculator. Nope, not that. If you do that, that's a mistake. You want to go to our VE calculator. And what you're going to do is you're going to, where's it at here? You're going to go to a point and you're going to get the RPM, the mass airflow, IAT, and baro, and you're going to plug all that in to the calculator. Well, that's a lot of work. And, you know, how do I say this? VE, if you ask somebody what VE ought to be, they'll give you a range, 70 to 100. Well, really? So if I have 75, is that good? VE is all, it can be all over the map as far as what it ought to be. Now, if it's really, really low, then it's like obvious. Everybody's number for bad is bad. But why not use something that's already on your scan tool? So let's use, why don't we use, where's it at? Where's it at? It's here somewhere. I know it's here. Where is, all right, it's right in front of my face, I'm sure. Engine load, yep, it's right in front of my face. So I'm going to put my RPM thing at 5,000, okay? That's kind of a common place to get VE, right around 5,000 RPM. So I'm pedal to the metal, RPM's going up, vehicle speed's going up, I'm leaner than snot, I'm in open loop, it should be rich. The mass airflow is, I don't know, maybe it's low, maybe it's high. I mean, I know, but let's say I didn't know. I'm looking at my engine load and it's 56. Okay, so engine load is like VE, and that is, if you're going to use it, you kind of need to know what it ought to be. It's a little more precise than VE, I think. It can be tricky because definitions of engine load can be tricky, but one thing's for sure, no matter what range of normal or good to bad, whatever you use for engine load, just like VE, if VE is 56, if engine load is 56, it's broken. Okay, that's not correct. Now, so our mass airflow number is low, our engine load is low, so we have a choice here. Either it's low because the engine is not breathing correctly, or it's low because the mass airflow sensor is reading correctly. So can we quickly differentiate? Well, if our load and mass airflow are low because the engine is not breathing, right? Whatever air is going through is being measured accurately. And so we shouldn't be leaner than snot. It would be rich in this case because it's open loop. So we just ruled out the one case. So I think we can say our mass airflow sensor is underestimating. Now, you may have noticed this, maybe you didn't, but if we look right here, well, let me get some stuff off of here so you can see it better. So let's get load off. Let's take a load off. That's right. Take this guy off. Take this guy off. All right. So now we can see now mass airflow at this idle point here. So right here, the vehicle came to a stop. We're idling in gear, and we have 4.29 grams per second on the mass airflow sensor. Is that good, bad? Probably good. Could we check into that more by looking at trim? Sure. But wait a minute. Before we waste time, look what happens right here. We got our mass airflow just went down to 1.84 grams per second. Okay. Sorry, that's not happening. That's a default, and that's broken. That signal is gone. And additionally, if you take that point there, if you take that point where it happened and look all the way to the right from there, every time we move the throttle, what didn't happen with that mass airflow sensor? It didn't do anything. So we just lost mass airflow sensor. Now, why didn't we set a mass airflow sensor code? Well, the code set criteria. So all of the onboard tests, every code that can set represents a test. And these tests run, they can run concurrently at the same time. They could run one after the other. They can run in any different numbers of ways. And so why this stuff happens? It happens. Sorry, that's what happens. Also, so you might be wondering, well, why didn't we set a code for the Bank 2 upstream sensor? Well, if you drive the thing long enough, it probably would have. Probably would have set a mass airflow code too. But the point here is, I got this broken car, and it needed a mass airflow sensor. And I got paid 2/10 to put the sensor on and 3/10 to diagnose the sensor. 5/10 to diagnose the mass airflow sensor and replace it. Can't mess around. I just said that now that mass airflow sensor is dead. What I could have done further, and what I did do actually, is I went to the connector, disconnected it, checked the terminals, make sure that the wires weren't, like rubber bands and stuff. And if I remember right, on this particular engine, the wires are pretty sturdy going to that mass airflow sensor. And so I checked the wiring, as much as you're going to get for a total of 5/10, and I put a mass airflow sensor on it. Now, if you want to go further with that and use a scope and whatever, and then go for it. And I'm not dissing anybody on that. And I'm going to break that clock one of these days because it always goes off at the wrong time. So anyway, so that's what happened this day. And so this used to say, this here, I'm going to fix it right now. So I'm going to go back here to my capture. Go to my notes. This is the actual note because I erased it or changed it. Come on, why you... There we go. Okay, so this is what it originally said, is this here. So what I did, evidently, is almost 15 years ago, I had this car. I pulled the code, I drove it, and I determined real quick, I needed a sensor. I typed the story in, and I saved it, and there it is, saved for posterity. So this thing is fixed, and so just wanted to share this case study with you, and we'll be doing more stuff later on. So with that, this is Captain Flatrater signing off. See you next time.